Pollutant control guidelines, past and present. So it is a very short survey or review of the proposed guideline in the past up to now. More the beginning and the end than the middle. But anyway, so we'll do my best, and you will see that sometime I'll make some link between the speed limit in the road. So in terms of outline, it will be really a focus on the impact of pollutant inside the museum to the artifact inside the museum, not what really happened outside of the museum. We'll do, as I say, a very short history of pollutant guidelines, and we'll spend a few time. This is probably a hard time for many, that how the quantification of damage can eventually help us to draw better guideline. And I will finally talk about one of the latest proposal of guideline for pollutant control. So we had to travel to the past, and the major step about guideline on pollution is the famous Gary Thompson in UK with his book The Museum Environment. It was published in 1978, and Thompson at that time, he was not the first one, but he was known already from the 1930s that had been quantified the impact of the pollution on the books and papers, and it was clear at that time that bookstore in the polluted area, industrial area, were much more damaged than bookstore in the countryside clean area. So basically, Thompson decided to pick up the typical concentration on the countryside and become the first guideline. It was achievable for most HVAC system, ventilation system, without specific gas filters. So he come with some number with his book. The unit of maximum concentration allowed are in microgram cubic meters. So for nitrogen dioxide, he said the limit should be 10, 2 for ozone, and 10 for sulfur dioxide. What we have to remember is those numbers are from the observation on paper, but have been applied to the general collection. So this is the picture of the second edition. Was somehow known as the Bible in conservation, and you could see that Thompson has very mythic position, that somehow he has a good connection with the Bible issue, if I could say. What's happened in USA? How the first guideline started? Well, in the American way, it started with a kind of a scandal. So Jack Anderson in 1979 wrote a paper about how the American archive was well protected or lack of protection. Jack Anderson was a very well-known journalist, investigator, liked to search, to try to see what the government is doing officially or non-officially, and he liked to do some digging in the archives. And then suddenly on this paper, he realized that the collection was under gradual destruction, fire, a lot of missing items, and also with incorrect support. Of course, the National Archive reply, and they say, well, it is greatly exaggerated, but somehow the door was open. So the Congress really want to hear what the National Archive has to say. But at the end, they conclude that they need to develop standards, and they develop many committees. They have created many committees on different aspects of the archive fields, and they have a meeting about indoor air quality that was run in 1983. They have 25 Participants were like archivists, scientists, and HVAC engineer, ventilation engineers. So the first step, they have to agree about what should be the air quality criteria. So it should be acceptable, measurable, not with a wet chemistry, but something easy approved direct reading instrument, achievable and sustainable. But then they also realized that uh, there were little conversation on the fact of the issue of interaction between the pollutant and the archival material. How bad are the pollutant? Which level do we have? Which level is dangerous? So they conclude a little bit by in absence of quantitative dose response relationship, the trend is, well, for those for the gas that we know with some limited detection, we rely to the limit of detection, and for the others, we'll kind of recommend use the best available technologies. Now you can really see that there were a push from the HVAC engineer or the HVAC industry. That means that on my table, we could see the document from the National Bureau of Standard in '83. That document was for the National Archive. They come with the number maximum pollution level similar to Thompson, but they add new pollutant like acetic acid, formaldehyde, hydrogen chloride. But then by lack of knowledge or lack of data, they say use best control technology. Now, the term of use best control technology, that become a trend. Either people use low limit of detection and out while sorry when the museum propose lower limit, then other institutions try to always match with the lowers that people propose. So at the end, it was kind of a direction of somehow, if you drive, it would have say like a slow, drive as slow as possible. Even at one point, people will say, well, we should ask for zero pollutant. It's like, please do not drive. Does it make sense? Probably not, because how much it costs to have very small amount of pollution in the building, and you have to remember that museum has other challenge, that humidity, have a fire, water damage, security, and everything. So there were a need of, instead of asking for the lowest and lower limit of detection, which tend to go lower and lower, maybe it was a point that we need to know, well, when bad is bad and which condition we really have problem, we should minimize that. So in 2003, I tried to compile, to collect what was the information known about interaction between pollutants and material, compile that in a book. And basically, I came with an approach which was from the risk assessment field, which was based on two approaches. We'll see that. So the first one, well, before it was based on the observed adverse effect, or when we'll see a critical damage, a small change of color, small change of pH, a small change of the physical resistance. So when we'll get a small damage or critical damage. Now, when we select a key or specific damage, now, how long it will take to reach that damage based on concentration and time. I come with the dose aspect. So we're going to be looking for the lowest observed adverse effect dose, which has the notion of reciprocity. It's a bit with a camera with the light and time. So the dose is like, if dose to cause a small damage is 10 ppb year, ppb is also a concentration, either you reach that dose with 10 ppb for 1 year for a specific gas and material, or it may take 10 years with 1 ppb. It's all the same dose. So how will we will determine the load from a specific material and pollutant? Here my example, we have a pigment, unknown pigment for you today, and it was exposed to 100 ppb of sulfur dioxide. So to measure the change, we rely on the change of color, and one way to quantify the change of color is by using the unit delta E, which is a change of color. And the critical or the lowest observed adverse effect was defined as a delta E equal to. It means that many conservators will agree that when the color change is 2 or more, it becomes significant. So the point is how long it will take to reach that change of delta E up to 2. In our graph, it take 0.5 weeks. So the dose become 100 ppb of sulfur dioxide multiplied by the time 0.5 weeks. Then we modify it to years, and we get a dose close to 1 ppb year. The second tool or concept we could use in risk assessment is the non-observed adverse effect level, called NOEL. So this is a tool that somehow at a certain concentration for specific material and pollutant, no damage is observed for an extended period of time. In our case, in our example, we have lead exposed to acetic acid. And as the lead corrode due to the presence of acetic acid, the corrosion layers will cause weight gain on the surface. So we have been exposed lead to acetic acid at different concentration over a different time period. And you could see that after 1 year, no damage had been observed when the concentration was at 0.4 milligram cubic meter, or if you want 400 cubic meter. That means that will be the NOEL for acetic acid and lead. That's kind of a useful tool to use in risk assessment. So I've done a compilation and make a generalized to a general collection, if I could say. So the approach of that table, still in microgram cubic meters, is how long a museum will accept one step of fading or small damage. Do they want to have a small change, small damage every 1 year, or every 10 years, or every 100 years? So this is the target for general collection. And because for general collection, some high-risk pollutant material interaction, such as lead and acetic acid, or silver and hydrogen sulfide, are excluded. So for example, if you don't want to see any damage for 10 years, this is the maximum concentration you should be allowed. If you be 100, all the concentration is divided by 10. This approach has very moderate success. One of the reasons is nobody was really sure which target to choose. And from what I hear, many people try to target the 10 years, but it was just a small amount of museum. There were few other standards proposed. So after CCI in 2003, some start to also relax and also use the approach of real knowledge of interaction between pollutant and materials. So a British standard was released in 2012, which proposed somehow a bit higher number. And of course, stay away from use the best control technology. Between Thomson and the end, they were much more standard, have been reviewed, and those reviews can be found in a paper published in 2018. It was called the Evolution or Specification for Limiting Pollution in the Museum, and I will give you the reference at the end of the presentation. Now, of course, controlling pollutant or guideline for pollutant is difficult because it's very easy to control, to measure temperature. Uh, you need pay a bit more money for relative humidity. And you have to buy your light meter somewhere, somehow, to a specialized place. But pollution is expensive. If you have low sensitivity, yes, it will be low cost. But if you want to have high sensitivity, well, the cost can go very high. And we fell on the trap. That means by recommending a lot of number, but somehow most of medium and of course many or most of the small size museum cannot afford to pay for investigate the pollution because it's pollution usually it's from one gases, and if you want to analyze many gases the price go up very quickly. So we have to find a new approach that some people can make step or be confident about what they can do. Here we come with the latest proposal. It was from ASHRAE. ASHRAE is an American association for the HVAC engineer, but it's also well known around the world. And since 1999, they have already a chapters for everything about ventilation for museum, galleries, and archives. And in 2019, they have the latest edition, which was a fully revised document. And David Tickett was also on that committee. And the pollutant section come with a new approach that we'll see very soon. And you could either get that table that we see soon from the ASHRAE Association website, or you could download it for free. You could get it for free from the latest CCI technical bulletin on pollutants. The new approach of controlling pollutant come with a three level, like basic, intermediate, and advanced level. So the basic level is hopefully what is achievable by most museum is you have just a basic control of fine particle and you have a strategies to avoid the most common problem found in enclosure like a display case or storage cabinet. The second level, intermediate, is yes, you have a better efficiency on a fine particle, but also we have strategies to reduce the risk of damage or to reduce the uncertainties on your approach or your strategies applied. The last level, advanced, is now you have a lot of resource, you have a lot of time to do a bunch of analysis or risk assessment, so you'll be able to better quantify the improvement of your action or proposed action so you could optimize your strategies. Let's see it on more detail. So at the basic, yes, at the building level, display case, consideration. At the basic level, you have particle filters recommended by Office Space or the LEED program certification, which is like they may recommend the MERV 13 as a specific type of filters efficiency. Inside the cases, the material that you use have to be recommended by the conservation professional. And you identify the object that tend to be at high risk from pollutant. So it would be lead, silver, some glasses, cellulose. At the intermediate level, you may need to improve the efficiency of the particle filtration depending on how is polluted your outside of your building. And then you may consider some spot tests to make sure that the choice of material is are the right one. In terms of consideration, you may want to avoid high humidity and high temperature. At the advanced level, as I say, well, the sky is the limit, so you could use with higher particle filter efficiency. You may even consider gas filter if it's needed. You may also consider if your cases should be very airtight or leaky based on the risk assessment, and do the airtight measurement to know what you have and what you want to have in terms of airtightness. And the maximum, if you really want to go to number, here my list of number, which is equal to the 1 year that we have seen with my summarized table from the book 2003. To conclude, you can see that this new approach allowed people to make action without going through expensive monitoring. So already small museum, medium-sized museum most museum can afford easily the basic approach, and then some intermediate museum may want to do a step further by doing some spot tests and getting more confident on their approach. And of course, a big museum with a lot of resource can go deeper on their risk assessment. So as promised, I show you the reference of what have been mentioned on that publication, and thank you for your attention.